Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, and welcome to the SEI Podcast Series. My name is Grace Lewis, and I'm a principal researcher and lead of the SEI's Tactical and AI-Enabled Systems Initiative. Today, I am joined by my colleagues in the Software Solutions Division, Alex Durr and Sebastián Echeverría, and by Kate Maffey, an Army data scientist, to discuss MLTE, a new tool that provides a process and infrastructure for machine learning test and evaluation. Welcome to the three of you. So let's start off by having you tell us a little bit about yourself, the work that you do here at the SEI, and the coolest part of your job. Sebastián, why don't you start us off?
Sure. Hello, I'm Sebastián Echeverría. I come originally from Chile in South America, where I worked for several years in the industry, working with ML models and LiDAR systems to measure different types of loads on trucks. And I came to CMU to get a master's degree in software engineering. And after that, the opportunity appeared to work at the SEI, and that's how I got here. I have worked on different types of projects over the years, starting mostly on edge devices and different methods to help people working at the edge. Then I moved mostly to IoT security, also focused on the edge, but a bigger focus on how to secure different connections when you have hostile environments. And most recently, I've been working on software engineering for AI, on how to apply the rigor of software engineering and practices to systems that have AI components. And that includes projects like Portend, where we are developing tools that help people developing models detect data drift in their models early. And that also includes MLTE, which is the project that we're going to be talking about in a bit.
What about the coolest part of your job?
Yeah, the coolest part of my job, I think, is there are many, but one that I always keep in mind is the fact that I'm always learning, because we have to use new technologies for the different projects that we have to complete. And we need the newest technologies to actually be able to rise to the challenges that we are trying to deal with. So the fact that we're always learning and always on the bleeding edge and learning new technologies is one of the coolest things of my job.
That is indeed very cool. What about you, Alex? Tell us a little bit about yourself.
Yeah, so hi, my name is Alex Durr. I work at the SEI for just over 3 years now. I'm originally from Sioux Falls, South Dakota, and I went to school at Dakota State University, which is in Madison, South Dakota. While I've been here, similar to Sebastián, I've been working on projects that focus on software engineering for AI, which has been both this MLTE project, but also a project called Tech, which was focused on developing a tool to collect information from different stakeholders and identify system mismatch in order to prevent long-term issues with machine learning problems. So another project I'm working on, and I have worked on previously, is the Vessel project, which is focused on container reproducibility. I think my favorite part about working at the SEI is having a very diverse team. We all have different backgrounds and different expertises, so there's always someone to talk to when you have different types of issues, and it's not like we're all working on the exact same thing, which makes the work really interesting.
It is a very diverse team, Alex. You're absolutely right. Now, Kate, you are an Army data scientist who previously worked at the AI2C, the Army AI Integration Center. You're also a co-creator and co-developer of MLTE. So tell us a little bit about yourself, how this collaboration with the SEI has been, and what is also the coolest part of your job.
Yeah, thank you, Grace. It's great to be here. Hi, everyone. I'm Kate Maffey. As Grace said, I'm a data scientist for the Army, and I have a little bit of an unconventional background academically. I started out studying Middle Eastern studies in undergrad and spent a couple of years working in Europe before moving to Pittsburgh in 2020 to do a master's degree at Carnegie Mellon University. And it was actually during the master's degree that I started collaborating with SEI. I worked on a capstone project with a couple of peers, and our advisor, Christian Kessner, recommended that we bring someone named Grace Lewis into our project. And so that's when my collaboration started. Grace was kind enough to help advise us throughout our capstone. And that capstone project is actually what turned into MLTE, which is the tool we're talking about here today. So I've continued to collaborate with SEI over the last couple of years. Since that, I think that was 2021. And it's been great. The SEI is full of really knowledgeable people who have lots of experience across industry and academia. And I think that's been an incredible part of working with all of them. The coolest part of my job is probably just that, frankly. It's getting to work with lots of brilliant and interesting people and really to have those interesting conversations where, you explore a technology that's new and you get people's input and you hear stories. I think that is really something that brings a lot of joy and fascination to my job.
Well, thank you very much. I'm glad you're getting to learn a lot more about our people. But we're here to talk about the MLTE tool, which was just recently released, and we will include a link to the tool in our transcript. So, Sebastian, can you tell us a bit more about why the tool was developed and some of the problems that the MLTE tool solves?
Sure. The starting point for the development of MLTE comes from the increase in the use of ML-enabled components in different types of systems. Since the development of the current generation of AI models is a very, very new in comparison to other disciplines, what has been seen, and we've also seen this in different surveys, is that there tends to be a mismatch between the expectations of the people developing these machine learning models and the people developing the actual system that is going to be using those models. So it's common for some of these ML models to work properly in isolation, but when they try to integrate it into the system and fill them and deploy them and actually make them work in production, there are issues that people were not really expecting. So the approach that we're taking with MLTE, which is both a process and a tool, is to try to help people when they are having this to avoid having this mismatch, basically, and to help them out and give them some pride and some guidance and some help to try to avoid these pitfalls and to try to actually make it easier for ML-enabled components to work in integration with the final system that's going to be deployed. And the overall way that we do this with MLTE is that the process helps you take a system level perspective of where the model that you're developing is going to be. And we start from the idea of quality attributes that the model and the software component that's going to be using the model has to achieve. And the process has a whole discussion, a cyclical, an iterative discussion between the stakeholders and the model developers first. After that, there's a lot of iteration also in terms of how to actually ensure that the model is meeting these requirements once you have defined them. So the process helps you guide that whole life cycle of development, and the tool helps you define tests and that can actually validate that your model component is meeting those system-wide requirements or quality attributes. The goal of the tool is to make it easy to automate and to gather that information so that at the end you can see if your model components are good enough for system integration or if you need more iteration in terms of meeting those requirements.
Yeah, that's great. So basically what MLTE does is it really takes a system perspective to testing of models where you're not just testing just the model, but you're testing in the context in which it will be used. So Kate, this MLTE started as a capstone project, like you said before. And obviously this was proposed by you and your team because this is something that you were seeing in practice, that this practice of testing and evaluation of machine learning models didn't exist. So from your experience, what are some of the reasons why so many ML models fail in production?
Yeah, there are a lot, as we all on this team know, and as I'm sure many listeners know. But I think there's two that really stick out that I'd like to highlight. And the first is sort of what one of the things Sebastian alluded to, which is really not understanding the system requirements when creating a model. So an example of this would be, someone's creating an image detection model, but they don't realize that the system it's going to be employed on is a handheld device, like a small camera, for instance. And that really affects, how the model is going to be able to perform. And so if you go into it as a model developer and you don't know what that larger system is going to be, you can really run into big problems that cause delays or just cause the project to not to work, have to go back to the drawing board. The second one is lack of communication. And this is really well cataloged in the literature, but it's also pretty easy to see in real life, as again, I'm sure many people have experienced. And that is that, there's a lack of understanding either in terms of the specifics that a model needs to do, or there's just, one person who has a lot of the operational knowledge. Perhaps that person is a domain expert, and they don't spend a lot of time talking to the model developer, for instance, who actually has to write the code. So this could lead to something like, again, to go with the image detection example, maybe there's an image detection model and it's only been tested and trained on, blue sky, green grass background, and it needs to work in an environment where, there's a desert or it's snowy or some other biome difference, right? That might seem like an obvious thing to work towards, but if you're a model developer and you haven't been having consistent communication with the people who know more about the use case, it's easy to see how that might break down and it might cause, some issues in terms of having a system fail, and especially having a machine learning component that doesn't fit well into the system.
Yeah, the communication is really a big problem, because what happens then is that as a data scientist that perhaps hasn't been trained in, software engineering and quality attributes and design and things like that, does what they know better, which is basically just a test for accuracy, right? And then you see all these problems because they're not looking at the system. Okay, so Sebastian told us at a very high level what MELT is. Kate talked about some of the maybe motivation for why MELT exists. So Alex, can you tell us a little bit about how MELT works and how it solves some of these problems that have been mentioned today?
So some of the issues Kate mentioned might sound simple at a surface level, but as you really get into solving them, there is a lot more there that needs to happen in order for these requirements to be elicited during the design time. So the MELT process, along with the negotiation card, are focused mainly on some of the things that she mentioned. So our research is focused around identifying things that need to be found and defined during design time, and then they can be discussed with the model developers and also the stakeholders in the project. So this will be things like she mentioned. There's things like how much CPU is available, how much memory is available, what kind of environment is this going to be used in? Because there are cases where a stakeholder will come in and say, I need a model that can detect X things in this image. And the developer will make that. And then there's so many other things that need to be accounted for that don't get accounted for. So MELT focuses around structuring a discussion with the negotiation card that will help you to identify all of these pain points that could show up later in the process. And then the MELT takes it one step further, and going past actually defining these requirements during this negotiation phase, it helps you also define tests that will allow you to ensure that these cases are being met. So this happens through defining certain pieces of the model during the negotiation card discussion. But then past that, it helps you to define test cases using the MELT library, and also running and implementing these tests through the test catalog. So one piece that we have of MELT now is the test catalog that I mentioned. So this focuses around having a resource for developers that are looking to test their models, and then allowing them to look at other examples of how people have tested their models in the past for different things. So for example, if you need your image or your model needs to be robust to blur, you can go into the test catalog and you can see, hey, how have people tested for robustness to blur in the past? And you can look at some examples, take inspiration for those, and then use that to test your own model and provide feedback and provide validation that your model is going to work as expected. Obviously, this is a very large source of knowledge, and it's not going to be pre-populated. We have a couple examples now that are come preloaded with the MELT library. We plan to expand these so we have general and widely applicable examples to ship with Melt. But the idea here is that each organization will run their own instance of Melt. And as the organization uses Melt and their developers make new tests for different scenarios that are applicable to the scenarios that they work in, they will upload those into the test catalog that is only available, again, within their organization. And then other developers in the future can look at those previous examples, look at the test catalog, and then there can be more cohesion and more just ease of use to actually get the tests started and structure them similarly. So that's one big piece of Melt, is that test catalog. And then the library, again, going back to the actual library portion. So once you have the test written, you have the test implemented, the Melt library also provides functionality to help you run these tests and provide a report and an easy way to export your results. So once you define all your tests, you can create certain pieces in the back end that are going to be redesigned slightly. So it was a spec previously, it's going to be changed, but that's still currently in progress. But the idea is you can define your list of test cases, your list of tests that you want to perform. And then once you have them all set up, you can have them all run, and we'll get one big output at the end where you'll have the results of each test, the pieces that were part of the negotiation card that were important to these tests, and you'll get one PDF export at the end of a report to say, hey, these are the things that I defined as my requirements, these are the ways that I decided to test them, and these are the results. And so the goal with this is that you can have your contractor say, hey, this is my report, these are the tests I ran on the model, and this is what I got as my output. And then if you are then transitioning that to a partner or to a customer, the customer can then look at those tests, look at the report, and then in theory, they could be able to rerun all of those tests and confirm that they're all matching and they have similar results and they meet the expectations that they set for the model. And that, as a whole, is the goal of Melt. There's a lot there and there's still a lot to go, but that is the goal and that is the structure that we have set up.
So to summarize, Alex, it seems like there are some key parts of Melt that are important for solving some of these challenges that were mentioned earlier. So one is the negotiation card, which records all these discussions that are happening between the stakeholders and that model developers use then to develop a model. The test catalog is also a big piece because, as we said before, a lot of data scientists probably don't know how to do all these tests. So being able to have examples really helps with the testing process. And also this idea that test cases are like integral to Melt, like that's the essence of Melt, and also that you can run a report that basically is going to show you whether the test failed or not. So that seems to address every one of the challenges that we mentioned before. So we've heard the word negotiation a lot. So Kate, why is it important to bring in stakeholders beyond developers to this process of ML testing evaluation? And how do you see Mel facilitating this collaboration and this coordination?
Yeah, we talked earlier about system requirements being a challenge to capture effectively, and also about communication. And really, those are two things that are core to making sure that stakeholders and domain experts are involved in the project. I think there is a tendency to want to isolate different skill sets within a project, but really what that ends up happening is there's a lack of understanding across the team in terms of what the system can and can't do, and even in terms of what means success for a system, right? And so having stakeholders involved, and especially when we say stakeholders, we could mean like a domain expert, we could mean a system owner, but we also could mean like a user, for instance. And when you think about different systems and the way they interact with the world and their environments, you could see why it would be really important to have a user give input and be involved in the process of, evaluating a project, but especially of defining the requirements for a project, because what means success could be important for our user to articulate, not just someone who, for instance, is funding the project or something like that. So that's why it's so important to have everyone involved in a project be part of the process, and especially at the beginning when we talk about system requirements and about how do we define success for this project. That's really critical. So what Melt does to facilitate this is, Alex described this negotiation card, which is an important artifact, but I think it's important to highlight that by having the negotiation card as part of a larger process, MLTE really tries to guide teams into having these formalized touch points where everyone that I just mentioned actually sits down, ideally together, and has a conversation. And, that might be something a lot of teams do, but what we've seen and found in, our collective experience is that's actually quite hard to get teams to do organically. And so by having this structured process and giving them not just the opportunity and sort of encouragement to sit down at the beginning of a project and then throughout it, but also to give that infrastructure. So when you sit down, it's not that you're just sitting down without an agenda. You have the negotiation card in front of you, and that really guides the conversation. It offers a agenda for discussion and allows for questions and discussion points that maybe wouldn't have come up organically, but are really important for both the developers and then the stakeholders and others involved in the project to think about and have a shared understanding of both at the beginning of the project and then as the project progresses and things change.
Yeah, so you mentioned something, Kate, which is touch points, which I think is very important, because the negotiation card is not something that is one and done. It is something that you revisit after going through the process that Alex said. You come back to the negotiation with the results, and you can say, you know what, I know we talked about this requirement, but it's impossible for this model to be this accurate or for this model to be this fast. Let's have a conversation again and let's redefine these points. So I definitely can see how the stakeholder involvement is important, not just once, but throughout the process. So the SEI is a federally funded research and development center. And a big part of our work as an FFRDC is to transition a lot of the research, the ideas that we have, to the public and to stakeholders in the government. Sebastian, how can people learn more about MLTE and about ML test and evaluation in general?
Yes, so as we mentioned before, we recently released version 1.0 of the MLTE tool. The MLTE tool is available as open source in GitHub currently, and the repository that we have there, it doesn't only contain the code for the MLTE tool. It also contains a lot of documentation related to it, including a description of the process that's supposed to go along with this tool, and also a substantial amount of tutorials on how to use the tool itself, and several demos that showcase how a person would actually be using the tool for specific contexts that we are defining in those demos. So there's a lot of material there to not just to get the tool, but to understand how to use it and how to apply it to the specific context that you want to use it in. We've also published a couple of papers that explain in more detail the thought process behind this and how these MLTE process and tool relate to existing body of work. Some of those papers are also linked in the GitHub repository. So currently the best option is to start there, and you can find a lot of different resources to learn more about how and when to use the MLTE process and tool.
So what I'm hearing is that people are going to have to everybody has to go to our GitHub website, download our tool, and obviously there's a big section there that says we welcome all feedback. So what's next for the three of you? What projects are you working on now? Let's start with you, Alex.
Yeah, so building on MLTE, we actually have the Continuum project, which is a 3-year LTP that I'm currently a part of. So it focuses on both improving MLTE, improving the MLTE process, but also largely on the transition of MLTE to the DoD and integrated T&E. So we want to take what we've built, take what we've learned, and show that to the world, show that to DoD, help them improve their practices so that they can learn from what we've done and learn from each other. So that's one of my big projects right now. And then my other project is, like I mentioned before, is Vessel, which is focused on container reproducibility. That one is also super interesting. You can learn more. That one has had a press release recently put out by the SEI. We also recently published our diff tool for container differences, open source, also available on GitHub through the SEI's organization. And those are the main things for me right now, the SEI.
Okay. Super interesting. How about you, Sebastian?
Yeah, as it turns out, I'm mostly working on the same projects that Alex is. In terms of the first project, Continuum, my current focus is to try to improve the user friendliness and the simplicity of the tool so that it can be more easily integrated into the workflows of people that want to use it. So we're doing a lot of refactoring to have the same functionality, but for it to be more approachable, easier to understand, easier to start to use, and make it simpler while still being flexible enough to work in the different contexts that people have where they may want to use the tool. And in terms of the Vessel project, I'm currently focusing on everything that's related to making sure that the transition of the work there is going to be smooth. So I'm working on both open sourcing the different parts that we're developing, ensuring that the quality of the tool is up to a level where it can actually be robust for people that are using it, as well as interacting with different open source developers of different libraries that we're integrating and working with them, so that the resulting tools that we're developing there can work properly when embedded in different workflows as well.
Yep, super interesting as well. And now, Kate, what is your collaboration with the SEI going to look like going forward? And how do you expect AI2C and other Army organizations to benefit from this collaboration and the results of this work?
Yeah, I'm excited to keep collaborating with SEI moving forward on the Continuum project, which, as Alex and Sebastian both mentioned, is 3 years of long-term funding to really mature and broaden the reach of MELT, which is super exciting. I think there's lots of organizations across the DoD that struggle with a lot of the same things that we're describing today. And especially as more and more people are looking to integrate AI and also data-driven practices, MELT has a lot of tools that are beneficial to those organizations and to the people within them. So I'm super excited to continue being a part of that with the SEI. And as for AI2C and broader organizations, it's really important to have a number of tools for the different issues that come up and to ensure the facilitation of projects that are challenging, because many of them involve technologies that weren't previously used or even processes that weren't previously used. For instance, going from something that was a little bit of a manual process to trying to automate it with data. All of those things are hard to do. And so having a tool like MELT that really helps to facilitate and give a set of guidelines for teams as they sit down to tackle those problems, I think it's super beneficial, both for AI2C and, as we said, with Continuum, trying to broaden the reach of MELT and bring these tools and this process to more people. I think that's really important for people to have something to lean on and for organizations to have some guidance and an infrastructure to help them throughout those processes.
Great. So I want to thank you all for taking the time to talk with us today about this work. And to our listeners, thanks for joining us today. We will include links in our transcript to all the resources mentioned in this podcast. The SEI Podcast Series is available in all places you can find podcasts: Apple Podcasts, SoundCloud, Spotify, and SEI's YouTube channel. And as always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.